Thank you, Dr. Singh, and good morning, everyone. So I'll just do one round check. Just is it the slide is clear? Is it
Yes, sir.
visible?
Yes, sir. Yes, sir. It is fine.
Thank you. So today the topic would be EV charger and EV in Indian market. And I hope I have gone through other session, basically the coverage that is done, and I think a lot of things must have been covered. And you had a dedicated session on EV charging station, so there may be some repetition, but I have tried to make it as particular as possible. And regarding EV India market, we'll see like whether I have tried to make it more like what is actually happening right now in the EV Indian market, and a very light discussion on actually what is the market potential. And since this is a faculty development program, I think you would be more interested towards the EV and related specifications. So the outline goes like this. We'll talk about the different types of chargers and the top three, like broadly if you divide them, plug-in charger, the automated connection type charger, battery swapping, and the communication. And I see that there is a dedicated session on communication. So I'll just, from charger point of view, I'll try to show what is communication really means. And regarding EV Indian market, we'll talk about electric vehicles, charging infrastructure, and battery. So since there are two sessions, so I'll try to I'll try to cover both of them within the timeline, and we can have a short question answer session at the end. Okay. So the first part is EV charger. So as you can see, the picture has nothing to do with EV charger, but this is really what is happening right now when a charging infrastructure company like Power Grid Corporation of India think about installing a charging station. So there are varieties of charger available, and the vehicles that are slowly launching in the market, and the vehicles that are a big hit in abroad market, and what are their corresponding charges, and are they adamant enough to have their own charger, or they have interoperable. So there are a lot of questions that pop up in mind when we actually decide that what kind of charger we are going to install in the uh, in the public places. For example, I just wanted to highlight here, like in India, there are there was one particular kind of charger which had a dominance of 100% of electric vehicle, but the corresponding and in the last 1 year, the corresponding vehicles are almost stopped manufacturing. So you can simply understand like how the market dynamics changes with the charger. However, we'll be focusing more on the technical sides of it. So there are, you must have heard about this AC and DC kind of charging, and several fast charging, slow charging, and it is really very tough to decide what is slow charging and what is fast charging, because it is in the point of view when it is defined against a kilowatt or voltage level. Because what happens, the slow charging, fast chargings uh, are not more like internationally defined. It is more like what is the corresponding country's highest level of charging and the lowest level of charging in the if you consider the kilowatt rating. So very easy to understand. All AC chargings are slow and all DC chargings are fast. No matter even if the DC charging is 1 kilowatt, we'll see there are DC chargers which are 1 kilowatt, but still they're fast. So this is the easiest way of understanding. So what generally happens in a AC charging, there is a converter that converts the AC to DC, because the battery only gets charged by DC supply. So there is an onboard charger on the vehicle which converts the electricity, AC current that has come from the grid. Now there is a limitation to the size of the converter because there is already battery, there is already a motor and several other things in the vehicle. So the space that can be accommodated to a onboard charger has a limitation, and because of that one, the maximum capacity of the corresponding charger goes maximum up to 22 kilowatt, and in some cases in the higher side vehicle, heavy vehicle, it goes up to 43 kilowatt. So where generally the AC chargings are installed, typically in your house, in your offices, and your parking. So all these three places, as you can see, these three places are basically where the vehicle stands for more than 1 hour or 2 hours of time, and where the AC charging can be done. So typically these are the three places. Now coming to DC chargers, in this case, what happens? The conversion happens outside the vehicle in the charger. So in this case, you can get a higher rate of charging, and typically in case of public places, congestion areas, for example, like in charging stations, those are located in retail petrol pumps. Those are called retail outlets, or metro station pickup drop area. And in case of highways, where the typical residence time is less than half an hour. So those are the places where DC charging stations are installed. Now, this is more like a pictorial depiction of what I just told. So what generally happens, you can say that grid supplies any kind of power. So if it is a onboard AC charger, then in that case, what happens? The conversion happens inside the vehicle, like it is shown, and the same power factor, frequency controller, everything remains same, and the power goes to the battery, and battery now supplies power to the electric motor and to the auxiliary places. Now these days, because of the trade-off between the battery that is used in the vehicle, there are some dedicated session I saw. So I will not go in detail into battery. So only thing is the battery size decides the cost of the vehicle. So because of that one, in these cases, these some vehicles, they use lead acid battery for this kind of auxiliary supplies, and the electric motor are definitely run by the battery. Now, in case of a onboard DC kind of charger, the supply gets converted outside the vehicle, and the procedure remains same. So further, how to divide the chargers into various types? There are basically four types of chargers, you can say, and based on their mode of operation, the charging stations, the chargers are separated. The very first one is the mode one kind of charger, where it is simply a socket. It's more like you charge your you simply you simply take out the cable and plug it into the 15 ampere socket. So maximum power goes up to 2.3 kilowatt, mainly because there is no communication between the vehicle and the charger. So there is a safety concern over here. So the international standard restricts the power supply to 2.3 kilowatt. Now, more two kind of charger, more kind of two kinds of, there is a in cable control box, which makes the communication between the charger and the vehicle. And because of that one, what happens, you can have a control over the charging, although you don't have a complete control over the charging, but yeah, the safety part of it can be taken care through this one. So the it is further extended up to 7.4 to 22 kilowatt of charging. And the third type of charger, mode 3 kind of charger, is again same AC charging, but it is only via communication. So what exactly communication means here? So generally what happens in case of a battery and charger, battery in the sense the vehicle. So in this case, the battery plays the master role and charger plays the servant role. So what happened whenever Even if you put a battery capacity of, let's say, 43 kilowatt, but your battery demands only, let's say, 1 kilowatt, then it will supply only 1 kilowatt over there. It cannot supply because the battery will not accept, the battery management system will not accept anything beyond 1 kilowatt. So that is a master slave relationship over here. So in mode one, that doesn't work. So because since there is no communication, so whatever is the power, it will go to the vehicle, and if it is something extra, it will get wasted only. So in case of mode 3, the AC charging happens only via communication, and the range has gone up to 43 kilowatt. So this kind of mode 3 kind of charging station are allowed to put in public places because safety concern is taken care. Now this mode 1 to mode 3, this kind of chargers are AC type charger. Mode 4 charging is the DC power supply based chargers. And here the charging happens same as only by communication. And communication in the sense the battery decides how much power it will draw. We'll go in detail about various types of chargers over here. Now, how do you define a charger? Like, let's say, like I am a, let's say you are my customer, and I wish to decide like I want a charger of this kind, and then I have to define something in that regard. So there are, if you, there are, we write technical specification when you purchase of almost like 40, 50 pages. So I have tried to consolidate all the things in this slide. Now the first one is the general requirement. In the general requirement, we define what is the type of charger. Type of charger, whether it is conductive type charger, I mean there will be a physical connection between the charger and the vehicle, or it is inductive type, or it is automated type. There are various types. We'll discuss all of them in this session. So we have to define the type of charger. The second one is the mode. The mode, like I said, there are 4 modes of charging, 1, 2, 3, 4. You have to define the mode of charger and the energy transfer, the how in which manner the energy is transferred. Then next one is the system structure. System structure, I have to define the regulation method. So in regulation method, what happens when a lithium ion battery, so like almost the entire EV market has gone into lithium ion. So I will not be talking about lead acid at all. So whenever I mention battery, it means a lithium ion battery. So when a lithium ion battery gets charged, so it goes through different phases, and there is a phase of slow charging, there is a phase of fast charging, then at the end there is a phase of slow charging. So typically from 0 to 15 to 20% of state of charge, it is slow charging. 20 to 80, it is fast charging, and thereafter it is again slow charging. So in the public places, when the chargings are done, typically they are done in the fast charging regime, that is roughly from 30 to 70 to 80%. So, in lesser time, you can quickly charge your vehicle. So in the regulation method, we decide whether it is because it will be a constant current charging or constant voltage charging, or it will be a mix of constant current and constant voltage charging. And it differs from battery to battery and based on the battery chemistry also. Then interoperability. Interoperability comes into picture that I put a charging station, and is it interoperable to the entire fleet that is available, or it is particular to a certain kind of vehicle, that it is only going to charge this kind of vehicle. So a lot of scope is there in this area right now. A lot of work is going on, and since the team here is basically research scholars and faculties, I would request that you may work in this area. And a lot of worldwide competition is going on in this one. For example, China had a competition that one charger that could charge all the vehicles in the world. And you'll be surprised that the competition failed. India is also hosting the same competition. So I don't see it is a very big deal. It is mainly because there is the patent related issues, and the disclosures are very less. So, but this is an area where if research and development is done in India, then it will help the industry, and it will help the prospective users of EV a lot. Then third is the place of use. So place of use is, I'm sorry, I missed like this interoperability. Another the China example that I gave last, like in the last session, I mentioned about the Chaoji charger that is being developed between in between Japan and China. This is kind of a outcome of this competition. So still the Chaoji is in development stage, so we never know what is going to be the output. Again, come back to the place of use. So place of use, you need to mention like where your charger is going to be installed, whether it is in a public place or it is in a basement or it is in your house. So based on that one, the IP gets decided. But typically it is always above IP54. Now the input and output status. So what happens, you need to define that this is the input voltage and current. And you also have to define that this is the output I want. Like this, I have this much of power available at my place and this much of power I want at my battery end. So based on that one, the system has to be designed in between. Then the battery backup. So in the charger also you need battery backup. This is mainly because what happens when power goes off, and when, because these are all commercial things, the energy consumption whatever has happened is the basis for your commercials. So the battery backup plays a very important role, that how much time it is holding the data, and because it is continuously connected through internet. So what happens when power goes off, then it continuously throws the data to the backend server, so you can have all the data. So typically 1 hour of time is considered in case of all the batteries. The next is the efficiency and power factor. So as far as efficiency is concerned, till date 94% is considered as the conversion efficiency of the charger, and this is mainly because of the converter that is used, and these days our best class also goes maximum up to 96%. So 94% is considered and the top end chargers, and uh, slightly lower end chargers can have a specific of 92% of efficiency. Power factor can go up above 98%, but because of the supply power and the variety of things happens from the discom side also, the power factor is generally considered 90%. But here you can if you can specify it properly and do the calculation only the charger, then the power factor can go up above 97-98%. And the fourth part is the environment and the mechanical part, because like I mentioned in the previous session, in India the batteries, in the electric vehicle batteries, we cool it. We have additional thermal management system, cooling system to cool it. But in other countries, they actually heat the battery. So it is very important to define the temperature, humidity, and pressure in which area it is working, what is the humidity of that area, and what is the temperature range of that area. So typically in India, we write 0 to 55 degrees centigrade, and places and some other places like we have some projects in northeast area, and there we have reduced it by another minus 5 degrees centigrade, but it works fine. And we have some plans of doing. It's already installed those kind of chargers in Jammu, but after installing, we find out that when the temperature goes below minus 10 degree, it doesn't perform that well. So it is like that is the situation. You have to be very much sure that what is the temperature range where you, and since the charger records everything, there will be warranty violation if you are not operating the charger in the given environment condition. Then ingress protection, like I mentioned, the IP is defined. Typically, 55 to 54 to 56 is the range in which all chargers can fail and fall. The next one is the, I'm sorry, I missed the spelling here. This is the cooling method. So cooling method are typically when the charger are of lower capacity, say below 100 kilowatt, then it is generally by forced convection. There is a fan inside it. But when you have a high-end charger and you have a power supply of, let's say, 500 kilowatt, 600 kilowatt, so in that case, your cable will become very, very big, and if it may have to carry 500 amps of current, and very inconvenient because you have to plug the charger into the vehicle, and that becomes very cumbersome. So oil cooling methods and are used to cool down the cable and make it thinner. Then the display requirement, because either the chargers are operated by mobile applications or by the touch screen that is available on the charger. So the display requirements are very important, and you have to define that what are the display parameters you want on the charger screen. The next one is the communication and billing. So there are multiple levels of communication you must have already understood. Just you can stop me anywhere in between because I'm considering a lot of things must have been covered in the previous session. If something is not covered, you can stop me and we can have a light discussion in that area. Now coming to the communication. So there is a communication between electric vehicle and a EVSE, that is electric vehicle charger. So this communication is basically CAN or PLC based communication. So this also you have to define. Then there is a communication between the electric vehicle to the central management system, and in between comes the EVSE. So the communication between EVSE and CMS is typically OCPP based communication, that is Open Charge Point Protocol. Then what kind of protocol? Like I mentioned, OCPP based communication, and what is the it has gone up to 2.1. OCPP 2.1 is there, but in India we are considering 1.5 and above is acceptable. So protocols are basically what happens. There is two parts of it. One is a compulsory part, other one is the elective parts of the protocol. So with time, the elective parts is not mandatory. So with time, when things become more clearer and all these elective parts become compulsory, mandatory part. And that's how the protocol moves on. So typically in India, we are using 1.6 these days. Then comes the grid responsive metering. So what happens, this is basically towards the time of use and time of day. If Discom is applying something, your charger should have the quality to have that feature on it, so that when you charge a vehicle according to the Discom's tariff, you can decide that how much you are going to charge to the vehicle. And again, the digital payment, the RFID card and the swipe machines, everything are built in these days to the charger. Then safety and testing, several testings are done. Typical whatever is done to the electrical equipment. So the over voltage, over current, over temperature, and the different, similarly the under voltage and under current temperatures. And the main testing that are done, so this earthing testing, the mechanical climate and EMC verification. So these things are basically done in a designated lab. These days, ARI and ICAT is there. So ARI is Automotive Research Association of India, located in Pune. So this is the oldest one where this charger testings are done. So basically, this is how, let's say you want to get involved in charger development or research and development. So these are the things need to be have there in your mind. And I think by understanding this, you can have an idea that how just with a charger you can start a business, and how several things are taken into care into this one, so it can be standalone, and it can be unmanned, and how because of the communication facility, how from remote you can manage, monitor and operate the charger. Now we'll discuss about the plug-in chargers. So this is as you can see in the figures, there are hell lot of varieties now available across the world, and the standardization to make it a single one, the interoperable, like I mentioned, is a challenge. So these are the types of charger that are available right now in India, sorry, across the world. So Sedemo charger is of originated from Japan, and we'll discuss in the next slides how individually. So they are now again used across US and Europe, because all electric vehicles are multinational companies and they fly throughout the world. And however, this is the typically the originating country. And IC61851 is AC charger, and then GBYT, this is a China charger, and all the electric vehicles in China are compatible to GBYT. And because of the huge market of China, they have decided that they will not adopt any other country's standard. So because of that one, the China's electric vehicles are not sold any other part of the world. But still, the demand is so high in China that they fulfill their business sustainability from the same country itself. So SAE, it is almost outdated right now, but usually from US. And CCS charger is originated at Europe. Now it is flourishing across the globe. Tesla supercharger is particular to Tesla, and it has a very high range. We'll talk about this power in the subsequent slides. And the last one is Bharat charger. So this was in 2017. It came into picture, and 2017, yes, 2017 it came into picture, and this is basically a more like you can say is a copy of what is already there. So IC001 is IC61851 inspired, and DC001 is GB/T inspired. So, but you can see the GB/T can go up to 187 kilowatt, but here we are using up to 15 kilowatt. This is mainly because what your battery of the vehicle can accept. So in India, we have not gone into that stage of affordability. We can have a vehicle of that cost, and it can accept a charging of 187 kilowatt. But this is also in case of, maybe this is for the bus also the case. But still you can see 15, and even the DC charger starts at 50 kilowatt over here. Now Bharat AC00, just a minute. So Bharat AC001, this is nothing but an industrial circuit. You may see like your air conditioner, official air conditioner, industrial air conditioner also use this kind of circuit. IC60309 is the standard for this one. But it has a three-phase supply, mainly because it has three outputs. Because it is covered in the standard. You can have a single output also, but typically since these are installed in parking areas and also, and putting three chargers at different places, you can have one single point, and there three outputs can come, and you can have a cable of different length, typically 5 to 10 meter cable they supply. So from a single point you can give for power supply, and from that one three vehicles can be charged simultaneously. However, the output is single phase over here, and the display in this case is something like it only shows 2 to 3 things, and however it doesn't communicate. There is no communication facility there in AC001, so you can only see when the vehicle plugged in or plugged out. So mainly by the color code of the light, then and the state of charge also it sometimes shows. But I think AC001, if you need this facility, you have to pay extra for that one. Then the fault condition, that is, which is obvious. This is again through alarm or by separate lighting. So typically in India, this Mahindra and Tata vehicles provide this charger also free of cost. One set will come free of cost with the vehicle, And in offices for slow charging, we install AC001 charger. And second is the Bharat DC001 charger. So like I mentioned, like the charger, we decide fast or slow from country to country. It is unlikely to say the 15 kilowatt charger, a first charger in other country, but this is what is the highest charger these days installed. Slowly 50 kilowatt chargers are getting installed, but this is actually a moderate speed charger. So like it's a the connector is GB by T based, designed from China, and the charger maximum capacity it can provide is 15 kilowatt, and it can operate at two voltage level, 48 volt and 72 volt. So in India, most of the cars are 72 volt, and earlier cars those are obsolete now. The Reva and E2O, not E2O plus. E2O were all 48 volt based chargers, 48 volt based battery. So this charger can be used over there. And the maximum current goes up to 200 amps. So this is the reason if you have seen this charger anywhere, you will see it will just supply 15 kilowatt, but the cable are very big, very thick cable are used here, mainly because of the lower voltage range. Now, second thing is the communication. So there is a since it's a DC charger and charging happens only with confirmation for by communication. Here the CAN based communication is used, common area network. This is very particular to electric vehicle kind of communication, and Mahindra and Tata vehicles gets charged, and Nixon doesn't use this kind of charger. So you can see there is a male and female part here, and there are multiple ports available in the charger, in the connector. So basically, when you say charger, the inside part remains more or less. It's mainly how the connector design decides the inside part of the charger. Typically, what happens, they have modular converters of the order of 10 to 20 kilowatt. So if you specify 100 kilowatt charger, they will provide 5 modules, and if you reduce it to 50 kilowatt, they will reduce it to even if you sometimes like recently we purchased a 50 kilowatt charger, but they gave us a 60 kilowatt because they have to do over again redesign, and so they made it 20 into 3. So we'll be deciding predominantly, discussing predominantly on the connector side. So like you can see over here, so there are 2 ports for DC power. DC power, one is a positive and negative. And second thing is the connection confirmation. You can see the CC over here. So this decides when the charger is plugged in. And when the charger plugged in, it gives a signal that yes, the connection is firm and the charger is properly plugged. Then once that is done, then from the second connection point of connection, it decides, okay, if it is properly done, can I read the battery status, state of charge? If that is done, then it is understood that the connection is proper. Only thereafter, only the power will start flowing. Then next one is the other things are for ground and neutral. And besides, they provide cables, like I mentioned, the CAN. So there are ports for the communication port, communication wire is also there. And besides, for the lighting of the charger, so you will see there are different light codes that are shown on the charger. Like this is for easy understanding of the user to know whether it is charging, finishing, or there is a fault. So they give auxiliary power supply, and one more port they usually provide. This is for the charger supplier, the manufacturer of it. So he can have a proprietary on this part, and he can have his advertisement, etc. Through this one too. The next one is a type 2 charger. So I'm basically going based on the I'm basically showing it randomly. The very first 2 were predominantly used in India, and now this type 2 charger is also used in India. And so this is the world's most widely used connector, although it is a AC charger. But due to its protection and its safety features, so it is getting a lot of name. But even if you say this is a 22 kilowatt charger, it charges the vehicle in 7 to 8 hours. Whereas this Bharat DC001 charger, it's a 15 kilowatt charger, but it will fully charge the vehicle in 1.5 hours. So you can understand the difference between an AC and DC charger, and why I was telling that DC means fast and AC means slow. Now, similarly, I have put a picture of Kona. So this is the port, as you can see. So if you see the top part of it, so where I'm putting my pointer over here, so this part fits into the charger. So what happens? This part, this bottom two points remain unoccupied. We'll discuss about it. And this top part gets charged from the type 2 kind of AC charger. So the slow chargings can happen here. But like I mentioned, this is mode 3 type of charger. Here, what happened, you have a 3-phase supply, L1, L2, and L3. So this ensures the power supply. The proximity pilot decides when the charging is firmly connected, charger is firmly connected. So this is something called pre-insertion situation. And once it is the charger starts getting the state of charge of the battery, it understands that okay, the connection is now pakka, and it can start flowing the charger. So this is called post insertion situations, PP and CP. These are very widely used terminology in case of a connector. Then these two, one earthing and one neutral, is common to almost all the chargers. And I would like to mention also, in case the charger somehow comes out, generally what happens when the charger gets logged in, and unless you remove it, there will be a button in all the chargers like you can see here. So when you press it, then only the charger will come out, or else through the OCPP communication, you can lock the charger. So it will get locked into the vehicle, like what happens in the commercial charging stations. The charger will get locked, and unless you make the payment, it will not get unlocked. So this is one feature. But somehow, if you somehow removed it, and you can see the amount of power that is there in the charger, it can damage anything. So in almost all the specifications, they mention that if the charger is removed, within 3 seconds, the power will cut off. If there is no communication setup, power will cut off within 3 seconds. Now the communication over here is PLC-based communication. The PLC-based communication, you get this additional benefit is that like the communication in case of CAN is limited up to the EV and the charger. So thereafter to the server you have OCPP. Same here, but in case of PLC, you can integrate because your discom supply also have if it has a communication availability, then they usually use the same PLC method. So you can have an end-to-end control, like from your discom's office also, you can have a control over all the charging stations. So that is an additional benefit you get over here. And you can see all leading car manufacturers in the world, including Tata, uses type 2 charger. Those are BMW, Opel, BYD, Volkswagen, Audi, and Porsche. The fourth kind of charger is the CCS, the combined charging system. So this is now because of its simplicity and at the same time with its maximum safety feature, it is the most widely used DC charger across the globe. So typically the power supply is above 50 kilowatt over here, and there are two types of charger, mainly because the North America, they have actually it was initiated and implemented over here there, and they have made a bulky setup, and the corresponding country is still fine with the style, and they don't want to change it. So for rest of the world, the type 2 is basically used in India and most entire Europe, etc. the type 2 charger. So you will be listening most of the time CCS2. So this is the story. And as you can see, this same figure I showed in the previous page also. So here you can see there are 3 pins, again the CCCP pin and the earthing pin. Then you have power supply on the bottom side. The DC supply would happen over here. So these 3 pins would go in the top 3. These 4 will remain open, and you have DC power supply from this side. So from the same port, you can have both type 2 and also with one port, you can have CCS power supply and also type 2 kind of power supply. The communication is typically by PLC. And here what happens, because of the growing demand of CCS, now a lot of other companies are also trying to adopt this one. So, and the power supply range has gone now above 500 amperes for some cases. And for that, they're using the cooling system of the cable, like I mentioned in the initial slide. And they have a wide range of uses, like I mentioned, Tata, Audi, BMW, Porsche, and Volkswagen. And CDMO charger. The CDMO charger was initially like I mentioned, was developed at Japan, but now very widely used across the globe. And the typical charger you will see is 62.5 kilowatt, and it has a voltage level of 500. Like I mentioned, the 72 volt for India case, most of other vehicles that you are seeing, Kona, etc., it starts from 350 volt. So here it is showing by 500 volt. Actually, it is up to 500 volt. I'm sorry for the mistake. And now, because of CDMO's style and it's advanced quality, and now again the revision of the specification is done. Now 400 kilowatt chargers are also getting adopted. And this is basically this 1000 volt, 750 volt, 750 volt, and all you will see in case of buses. And you can see this is a picture of Nissan Leaf. So you can see if you have CDMO charger, then you have to provide 2 ports in your vehicle. So this one is for the type 2 charger that we discussed, and this one is for the CDMO charger over here. So this is the difference between a CCS plug and in case of a CDMO plug. I delivered it showed here. And the communication over here is again CAN-based communication. And types of ports remain more or less same as compared to a DC charger. And you can see mainly the Japanese car makers are using the CDMO. And we're expecting that the Maruti's upcoming electric vehicle also may be based on CDMO, but we're not sure. Now, the last one is the supercharger by Tesla. So this is one charger which is exclusive in nature. So it will be only fitted with Tesla vehicle, and the voltage level goes up to 480 volt DC charging. And there are different levels of charging, 72, 150, and 250. And it is understood that if you see the port in the vehicle, it is more like a type 2 connector. But however, you cannot plug in a type 2 connector over here. So like I mentioned in the beginning, the adamant of some players, this is what is there. So because of that one, Tesla gives charging free of cost throughout the life of the vehicle. And they have 1,500 charging stations in US itself. And however, but they face a lot of resistance in other continents. So in Europe, the Tesla Model 3 is now actually equipped with CCS inlet. So CCS charger can be used directly into that one. This is not that one. This is the typical. This Model 3 port would be different, like I showed in case of Type 2. Now this is what we discussed above are all conductive kind of charger, like the charger has to actually fit into the vehicle. But this is not that easy for all the cases, because when you have heavy vehicles and it takes care of transportation of public, then you cannot have all this additional work and you have to run all the day. So I'm talking about buses. So in that case, the automated form of electric vehicle charging comes into picture. So as the picture depicts here, so there are two kinds of automated connection kind of charger, that is pantograph and inductive charging. And this is the manual type of charging that we discussed till now, the plug-in charging. The next one is the automated, where the vehicle would only have to come to a spot and it will not do anything extra. I mean, there will not be any human intervention to get the vehicle charged. So either the charging happens from top, which is called as pantograph charging, or the charging happens from bottom, which is called as in the inductive type charging. Now pantograph charging. So typically what happens, it is a high conductive transfer of energy transfer and happens very short time. So generally it is very famous in Europe and also because they have a wide road. So what happens, this kind of structures are put on the road. So let's say one bus came and it stopped at a point. So what will happen, from top of its on the roof of it, one structure will go up and get connected to the power supply, maybe for a time period of 1 minute, and a burst of charging will happen. The typical capacity of this kind of charger starts at 120 kilowatt. So you can imagine like how fast it will charge, and it will charge for only 1 minute or 2 minutes, and it will make the vehicle ready for another 20-30 kilometers. So again, it will go to maybe if it is ready for another 20-30 kilometers, it will go up to another 10 kilometers, and again it will get the opportunity, I mean, quick charging over there. So there are two kinds of, again, chargers in pantograph. One that is top-down or inverted type of charger, and second one is the up or rooftop charger. So if you see, the left side is called the up and rooftop, and this is the top-down and inverted charger. So what happens in case of top-down, this is the charging what happens on the road. Like I mentioned, it will when it is on the road, it will go stop and it will again move to the next point. So it is otherwise called as opportunity charging. So when it is basically done during the daytime, when the vehicle has to move around the day, and here, because it is in the public and multiple vehicles has to get charged from the same point, so there are actually no communication port that is continued over here, like we mentioned in case of CAN PLC. It physically connects to the vehicle and the charger. So what happens, like we do our Wi-Fi and LAN system. So basically here Wi-Fi system is done, and the moment the vehicle reaches the point, the Wi-Fi handsets each other, and it understands this is my vehicle, and it starts charging. So this is top-down charging, and the second one is up and rooftop charging. This is also of the same kind, but what happens, this charging can do slow charging also. So you can plug it in the night time when the vehicle is at the rest, and it will do the slow charging. But it is also equally, it is possible to do the charging at a faster rate also. So this is what happens when in the lunch break time, or when the vehicle goes back to the stop, and it has a residence time of 15-20 minutes, or the driver changing happens. But at those kind of time, this charger is used, and this is basically the style is one upgraded version of CCS. The connector is there on the top, and there is a physical communication between the charger and the vehicle. Now the other type of charging is inductive or wireless charging. So what happened, because this electric vehicle is the next generation vehicle, which is it is replacing a existing transportation system. So what happens, the infrastructure is a huge obstacle when you develop the charging infrastructure. And the same road you have to, now the route remains same, the vehicle changes, now you have to provide charging, and you don't have space, like for example places like Delhi and even your New Delhi, where the roads are not that much wider, so you can have another charger and you have to have a footpath. So this wireless charging comes into picture. What happens? The entire charging part goes below the road. And what happens when the vehicle comes to the charging station? It communicates with each other, and there is a wireless communication that sets up, and it understands that this is my vehicle. Then what happens? A pad, a secondary coil from the vehicle that comes down, and through inductance, through a electromagnetic field that is formed by the primary coil that is sitting below the ground, uh, starts uh, powering the vehicle. And they are come typically in pads. So if you see here, there are 4 pads. So they may be of 200 kilowatt. So it is again, the speed of charging is high, but the losses are on the slightly on the higher side. It has not so much developed, and only in some parts of Europe this is used. But yes, where safety is more important, space constraint is there. So this is a huge hit in those areas. For example, the Disney World's entire roller coaster is now electric, and it is on wireless charging. Now, another mode of charging is battery swapping. So, battery swapping is famous when it comes to a lower range vehicle, but used in commercial places. So, you don't have to spend a lot of time in charging your vehicle. So, the swapping can happen in single-digit minutes, maximum 3 to 4 minutes it takes in case of a e-rickshaw. I hope the battery swapping is covered in the EV charging season. Now, what generally happens is uh, there is a battery swapping outlet where the vehicle will come with a discharged battery, and it will give the battery, and it will take a fully charged battery. Now, what happens? This battery will go to the charging station, and it will get recharged, and through logistic, it will come back to the swapping outlet. And I'll talk about the charger in detail over here. So you can also skip this part. You can have a small, just one charger, and this setup can come over here, and it can be called as battery charging cum swapping station. So these are battery charging and swapping station. Presently, what is shown over here is mainly when you don't have power supply available at all the points, and you are more dependent on a single source of power. For example, in the metro stations, bringing power to the ground level is very much tough. So, but every 5 or 6 stations, they have a substation. So you can install it there. The entire setup, you can bring a lot of power and charge your batteries, and you can send to different metro stations your battery. On the other side, if you have power available in the ground, you can have just some 23 kilowatts of power, and you can charge multiple batteries. So we'll discuss about charger in detail over here. So what happens? This is the SLD of a 16 channel charging station. So like I mentioned in the beginning, that the DC charger over here can go as low as 1 kilowatt too. So here what happens in the battery swapping station, like showed in the previous figure. So at a time, more than 20 batteries can also be charged. So the battery capacity is typically 1.5 to 2 kilowatt hour, one set of battery, and it gets charged by a 1 kilowatt power supply of DC, and at a speed of 0.5 C. So it takes 2 hours to charge a let's say 1.5 to 2 kilowatt hour battery, and simultaneously it charges all the batteries. So at a single point, you can charge up to, like at a single supply, you can charge up to 20 to 20, uh, more than 20. So typically they put 21 numbers so that the supply, the RYB, there can be a balance between the variety of supply over there. And they have a communication, and because this is DC, so you can, even if the 1 kilowatt charger, you can charge the battery in less than 2 hours. And there is a communication available over here, and because of this CAN bus, you can see the state of charge, the state of energy, state of function, and the temperature, voltage, entire thing of the battery can be known each and individually through the CAN power communication, and you can actually control the operation of the charging station through this one. And they usually use color codes to know that which charger is which the battery has got charged. So once the battery is charged, then let's say it turns green, and you can plug it out, and you can put a another discharge battery over there. So this is another kind of vehicle. So like I mentioned earlier, that the vehicle's cost is very much dependent on the size of the battery. But when you are living in a city, and you are not traveling very often to outside the city, then you actually, if your battery capacity is also 100 kilometer per uh, your total battery capacity can cater 100 kilometers is more than enough. Like I stay in Gurgaon, I travel only 10 kilometers a day. So if I use a huge battery in my vehicle, it doesn't make much sense. And let's say, but I'm going to Jaipur or Dehradun, then in that case, my vehicle's battery will not be sufficient. So you can have a range extender battery. So what happens? There are space in the vehicle, and you can go to a battery leasing company, and you can lease a battery from them, and by adding that one, your range can go up to, let's say, 200 kilometers, 300 kilometers. So you can travel to the nearby city, drop the battery there, again you go around, and again while returning you can have the battery. So this is a model that was widely followed by Tesla in the initial days, but it needs a lot of robotics, like you can see over here. So because of that one, things doesn't work well, and it has stopped by Tesla has stopped, and many other companies have stopped this kind of charging, mainly because of the uh, uh, people doesn't prefer, and they have a fear that okay, some nothing should go wrong. So a lot of research is still going on in India. Also, Mahindra and IIT Madras are working in this direction. They have already developed the prototype to have a extended battery in the vehicle. The communication, I hope the communication is must have covered in the previous session. So I'll just quickly explain this picture, because the entire charger thing over here cannot be completed without this one. So the electric vehicle and charging station. So there is a communication that happens as per CX1851, which is nothing but the part of OCPP protocol. And the 15118 is ISO 15118 is defined by vehicle to grid or vehicle to anything concept. And so there is a charging station operator, and there is a e-mobility service provider. I'm sorry for the spelling mistake over here. So the charging station operator and the e-mobility service are the on-ground players who actually charge your vehicle in the public places. So, but what happens? Let's say there are multiple charging station operators, and uh, a user do not have to have multiple apps to control the to know where the charging actually happens. So for that purpose, there is a roaming protocol that is there. So for example, let's say Google, some days after, you will see that EV charging stations are multiple places, and it will give you facility to charge your vehicle at any of the charging station. So in that case, the e-mobility service provider will come into picture, and the charging station operator will have to adopt the roaming protocol, so that it will get onboarded on the e-mobility service providers platforms, say Google, and let's say this is power grid. So what will happen now? Any customer through this one can access my charging station and do the charging at this place, and also can make the payment. And these are the varieties of protocols that fall under the roaming protocol. And simultaneously, the distribution utility can also control the charging station, because like we mentioned about the smart grids and all, to control the to reduce the augmentation that has to be done for electric vehicle. So they can have this open smart charging protocol or demand response type of protocol to actually control the charging stations. So this communication plays a very important role, and everything starts from the charger. So the charger plays a very important role that throws the data. So charger's communication has to be kept in mind all the time. Now this covers the first part of the session. So we'll talk about EV in Indian market, and we have last half an hour left. So is there any question till now, or shall I cover the questions? I think it is better if I cover the question at the end.
Yes, sir. Yes, sir. Whether you can continue and we can take up in end.
Right. So you can see the numbers over here. So have tried to consolidate numbers from 2015, where actually EV starts flourishing in the country. And you can see in the two-wheeler segment, before there are a lot of drive of EV was there, still the number of two-wheelers were on the higher side. So almost 23,000 vehicles were sold in the year of 2015-16 itself, and it has gradually in the last year 1.5 lakhs two-wheelers are sold, and present this year it is understood that it will if you consider the segment of scooty in the two-wheeler. I mean, if you exclude the bikes and on the higher side two-wheelers, and if you consider scooty kind of things and the two-wheelers, it is understood that 50% market would be covered by electric two-wheelers. So this market is flourishing. The second market is the three-wheeler market. This was what happened. This was the most deregulated market, and initially there was no registration of three-wheelers in India. So because of that one, the numbers are always a bit conflicting over here. So however, in you can see in the year of so these numbers, you can see it varies from year to year. So roughly 6,30,000 electric three-wheelers are sold in 2018-9, and this number, this 90,000, is not yet confirmed, and this is a media report that maybe 90,000 are sold, but mostly it is understood that even if you include 2-3 manufacturers like Activa, Kinetic, etc., so they have sold more than 30-40,000 of three-wheelers. So this number would be definitely bigger than 6,30,000. But since the regulations are slowly capturing this area, the numbers are definitely good. Like if you see in Delhi itself, I think there are more than 5 lakhs three-wheelers available. And in cars, so cars, the number has slowly increased, and in the last year there is a dip in the number. This is mainly because Mahindra has stopped manufacturing E2O Plus, and because of that one, there is a dip in number. But if you consider present year, only from two models, that is MG ZS EV, the number of vehicles booked are roughly 2,500, and Nixon EV of Tata Motors have already sold 2,000 electric. So the number only from these two itself, it is more than 4,500, and there are other models, Kona, Tigor, and all. We'll see those things in the later slides. So it is expected that this year the number of cars will be much more than the previous years. And buses India was very slow in adopting buses, because the ecosystem of bus is closed kind, mostly by the state transport units. So they have to change the infrastructure, and they have to get separate power connection. Several things are involved. So because of that one, the number are a bit on the lower side. However, like I mentioned in the previous session, 5,595 buses sanctioned in 64 cities. This is like 30% of the number of buses sold in 1 year. So if this number can be realized this year, it will be a tremendous thing for the country. Besides, a lot of new companies and the world's most disruptive company, Reliance, is introducing GeoMart, and its entire delivery chain is based on electric three-wheelers. So if again, if this gets realized this year, then this number will be astonishing to everyone, as you know from the Geo experience. And similarly, there are other companies. They're introducing smart delivery, e-cart, e-subji, oiler. So these are several companies. They're coming with three-wheeler logistics. And like Amazon, Amazon's delivery is now completely on E3 wheelers, electric three wheelers. So these numbers are expected to be on the very much higher side than the previous years. So the EV models in India. So if you see, I have tried, although it is not possible to gather all the names and corresponding numbers in one page, but I have tried to gather as much as possible. So in India, there are presently 6 kinds of vehicles that are flying. So there are a lot of media announcements that are having happened that next year these vehicles are going to be launched. But these are the vehicles that those are flying, and of this, I think E2O plus they have stopped manufacturing. So, so the first two belongs to Mahindra, and the range of E2O plus is up to 120. Mahindra 180. I think it has still gone slightly gone further on this front. I will see those updated numbers in the subsequent slide. And both of them are charged by our Bharat DC001 and the AC001 charger. And Tata Nixon, the battery capacity is 30.2 kilowatt hour, and it gives a range of 300 kilometers corresponding to it. The charging is CCS, and as you already know that the battery capacity and the range are directly proportional to each other. So Tigo, same model, the range of 140, but they are coming with new range every quarter. I think this range has gone more than 200. We'll see in the dedicated slide for e-car. And Hyundai Kona has a range claimed of 450 kilometer CCS, and MG's is 340 kilometer CCS. So these numbers and these are from the manufacturer and from their website. So there may be some linearity gap. Like you can say 40 kilowatt hour is giving 450, but 45 is giving 340. So I cannot answer that one because this is received from their website. The electric three-wheelers, two-wheelers, this is a very fast-growing market right now. And Hero Electric, Ather, Okinawa, Avon, Bajaj, Ampere, all these companies are Indian, completely make in India companies. And they're doing extremely good and selling products in lakhs. And the companies like Ather start up from my college, and it is now 750 crore company within a year of 4 to 5 years. And the range of the vehicle and the comfort is extraordinary. So, but this is more like private vehicles, and others, they're also catering into commercial. Like Okinawa, you will see the vehicles are also so rugged that they're taking care of commercial transportation too. Now, three-wheelers, there are several companies, and like I mentioned, the numbers were not registered earlier. So I have mentioned Kinetic, JM, Goenka Electrica Motor, Lohia, and there are from Trio, and there's several other companies. And these are the this is the area which doesn't get a lot of support from government, but it has flourished by itself and is a standalone you can say EV model. And the battery capacity can go up to 6 kilowatt hour, and plug-in swapping both is possible. And buses, India have currently three types of three companies: Tata, Ashok Leyland, and Olectra. And same, the range is up to 250, and the charging can be done by plugging and swapping. So these are the three most sold electric two-wheelers in India, and Ather, Hero Electric, and Okinawa. So typically the battery size goes up to 1.5 kilowatt hour over here, and the range is maximum 100 to 120 kilometer. And if you go for a lower model vehicle, and you can have a say 800 watt hour or 1 kilowatt hour battery, then your range can be up to 70 to 80 kilometer. Depending on the usage, you can decide, and accordingly the price will change. And now coming to the speed, the maximum allowable speed for these vehicles is 45 kilometer per hour. And there are other vehicles in the same segment, and they are of 25 kilometer per hour. So generally, as per government India's MORTH rule, if your vehicle speed is less than 25 kilometer per hour, you don't need a license. So there is lot of interest towards those kind of vehicles. And next is the charging time. So if you do it the charging by plug-in, then it will take roughly 5 hours of time. And the batteries are also detachable. For example, if your vehicle is in, you are staying in an apartment and your vehicle is parked in the basement and there is no power supply, you can actually take out the battery and you can bring it to your home, and you can do the charging at your home. It will take roughly 4 or 5 hours, and it will be ready for the next day. And if it is a swapping, it is for commercial purpose. You can use battery swapping model, and you can just by swapping the battery, it can be charged within 1 or 2 minutes. The three-wheeler market, I deliberately put this picture because when three-wheeler comes into picture, we think about e-rickshaw and e-auto. But actually, these days, the garbage collection vans, the logistics are actually dominating the market. And there are a lot of this is also covered under CSR. So even a lot of companies like Power Grid is also facilitating the municipalities to with this kind of vehicles. So battery goes up to 6 kilowatt hour. Modular in nature means you can have 3 sets of battery or 4 sets of battery, and each can be 1.5 to 2 kilowatt hour. And if your range is less, you can have 4 kilowatt hour also in total. And the segments are e-rickshaw, e-auto, cargo, logistics vehicle. Based on the capacity of the battery, you can decide the range. Typically, here 1 kilowatt hour battery, if you are using, then the range of that one corresponding range will be 20 to 25 kilometers. The speed, if it is a e-rickshaw, maximum up to 25 kilometer per hour, and above that one it goes up to 45 kilometer per hour. So in case of e-rickshaw, because of this speed range and also the motor capacity, it is not advisable to use it in high ramps, and even in if you consider Delhi. In Delhi, it is not allowed to go over the flyovers, etc. And the charging time, same. It takes 5 hours if it is done by plug-in charging, and maybe up to 7 8 hours also. And if it is done by battery swapping, within minutes, the vehicle can be ready. Now e-car we have already mentioned. So these are the different vehicles currently available in India, and you can see the Bharat-based charger, Bharat-based vehicles. The ranges are slightly on the lower side, whereas CCS it is on the higher side. So these are the models; those are available. CDEMO India currently there are no vehicles. If you see the entire fleet of vehicles that is there in India, roughly 10,000 vehicles are there. Out of them, 70%, 7,000 vehicles are private and 3,000 are by fleet. And the DC based DC001 based vehicles are of 80% covered 80%. However, the CCS based vehicles are very fast growing. You can say in the year 2020, most of the vehicles those are sold are of CCS based chargers, CCS based vehicles. So currently these are the top three electric cars in India. Now e-buses. So e-buses, typically the battery capacity starts at 200 and above. But if it is a smaller city, then you can plan for a lower range battery. So typically, if you are using 1 kilowatt hour of power, then sorry, if you are using a non-AC bus, and for 1 kilometer, you will be needing 800 to 900 watt hour of power, and if it is a air conditioned bus, then you will be needing 1.2 to 1.4 kilowatt hour of power. So accordingly you can design. So based on that one, you can design, and modular in nature, because in battery in here the one single battery comes of this order of 45 kilowatt hour. So let's say you have a range of less than 200 or 150 kilometer, then you can say 120 kilometer, just for ease of understanding. Let's say 120 kilometer, then you can have three modules of battery, 135 kilowatt hour, and do the calculation, and it will fit it. You can have a opportunity charging in between, top up you can do, and that will be fine. But let's say you have a public transportation concerned over here, and you have to travel 250 kilometer, then accordingly you can have another sets of battery. So because this is modular in nature, the benefit that you get is, the batteries are all dead weights. They don't, although they you drive your vehicle, but they add up a lot of weight to your vehicle. So the lesser the battery is, the more mileage it will provide. Then the range can go up to 300 kilometer. Currently, as per in India, the maximum range is 300 kilometer, but there is no restriction. You can have batteries are kept on backside, on top, on chassis, and multiple places. You can put the battery and make your vehicle as longevity as possible. So this picture I've shown is from Gujarat, where the charging is done by battery swapping. So this is how the battery is removed and new battery is inserted. And definitely plug-in charging is possible through this one. EV chargers. So currently there are these types of charger. Almost all the chargers that we discussed now are in India, and excepting CHEDEMO, all the chargers are in use. So I have given some tentative price over here, what generally it costs. And these are some of the companies. Exicom, Okaya, and Delta are the dominating companies right now in India, and others are slowly building up the market. And so this is the pricing. Now battery part. So India is, as far as lead acid is concerned, India is a multi-billionaire market. However, the lithium and battery are very fast catching up the speed, and these are the major companies who are actually supplying the battery, because they do only mostly assembly and battery management system, and the sale is imported from other country. Currently, if you purchase a 1 kilowatt hour of lithium and battery, the cost is roughly 20,000 rupees per kilowatt hour, and the efficiency, uh, the the weightage is something like 7.5 kg per kilowatt hour. So these numbers are very important, because, for example, if you have a two-wheeler and you want to extend the range, you roughly get 30 liters of area, 30 liters of volume below your seat. So that much area is only available with you to put the battery, and along with its cables, etc. So these numbers have to be there in mind, that okay, when you are deciding what will be the battery size. Similarly, like I said, in case of buses, it's a dead weight, and it is applicable to all kinds of vehicles. This is the situation in India, and the things are changing very fast. The 7.5 kg per kilowatt hour is the latest thing that is achieved. Earlier it was 10 kg. For example, like I mentioned, the two-wheeler, you have to, let's say you want to bring the battery to your home. The 7.5 kg is not a very big deal if you need to just bring it to your home. But say it is a lead acid battery, 1 kilowatt hour will roughly 30 kg. So you cannot bring it to your home. Then next is the testings are very much important. ICAT and ARI institutes are involved in testing of these batteries. Now this is slightly overboard. I thought maybe you would be interested in knowing the market that is there in India right now. So no, not right now, the projected market in India. So I have only sold the EV charging infra market. If you are interested to know more about it, you can write to me. I have some articles. Those are so decided. I mean, presented to Niti Aayog ministry. They can give the more larger picture of the entire auto industry, the electric vehicle auto industry. And I have already showed it about charging. So, like I mentioned in the previous session, the target to have 30% of e-car by 2030. So, if the target is met, the market potential for charging station alone is 3,83,000 crore. It's a very promising market, and it has considered two-wheelers and e-buses too. And Niti Aayog, a study was done by Morgan and Stanley, and they have expected that if 30% of e-car share is achieved by 2030, the market potential will be 2,17,000 crores, which is substantial to have a transition, to accept a transition. If this is the market that it can give, this is sufficient to transit into electric vehicle domain. And it is anticipated that the EV charging market forecasted, let's say, 15% share. Government has a interim target of 15% by 2024. Although it has not documented anywhere, but it was a press publication by Prime Minister's office. So if that is achieved, then by 2024, the total number of vehicles sold will be 9 millions. And of the actually 58 million vehicles sold by that time. And the charging points requirement will be zero point 0.7 million, and the corresponding investment will be 43,000 crores. And from 2024 to 30, if the numbers, the 30% is achieved, then the vehicles sold will be of the order of 21 million, of the of 69 million sold in that period. And the charging points would go up to 1.7 million, catering an investment requirement of more than 1 lakh crore. And it is envisaged that the total vehicle numbers by 2024 will be 316 million and 385 million by 2030. This is the wholesome number that can say. So with this, I close my session, and there are still 7 minutes there. We can have a discussion, question answer. So thank you so much. I am giving my email address and the mobile number is available here. And if there is something, we can definitely write to me. And if I fail to answer any question right now, that I will be happy if you can again contact me through this one. Thank you so much.
Thank you very much, sir. Now, participants, we are open for the question answer sessions.
Good afternoon, sir. Hello.
Good afternoon.
Sir, I am Saravanan from Chennai.
Hello, sir. Yeah.
If you are buying any battery on a specific kilowatt hour, like 18 or 20, like that, is there any ready-made BMS available, or we have to do our own?
No, sir. Generally, what happens, this lithium-ion battery, the BMS is inbuilt in it. Unlike your lead-acid battery, the BMS is inbuilt in the battery. So you don't have to purchase any separate BMS. It is inside the battery.
Okay. Thank you, sir. Thank you. Very informative session, sir. Thank you.
Thank you, sir.
Yes. Any other questions, please?
There may be some difference because I have assumed that a lot of things must have covered in previous session, and I'm sure they must have covered.
I think questions are not coming up. So, sir, I can put few questions. I would like to know, since you are in the smart grid department, sir, I would like to know one thing. Like when we will be integrating this EV in the grid, so we have some like positive and negative impacts of EV in the grid. Sir, is there any like means like anything which is in the planning level, or you need to like fear or scare like when we will be having a lots of EV in the grid? So is there any like means considering the negative impact? So are you means taking care of few things which are means expected in the near future, like which may have a
Yes,
negative impact? Yeah.
yes. Uh, Thank you. That's a very good question. Actually, the EV will have different stages of impact on the grid. So it will definitely have an impact on the distribution, and cumulatively the distribution will have an impact on the grid. Like if I'll go from the top side, let's say from the transmission side. So what generally happens in India currently, the peak demand is roughly 160 to 170 gigawatt, and our total installed capacity in India is 370 gigawatt. So there is a 200 gigawatt additional available in the country, and the transmission system is actually designed for 370 gigawatt. So if you even double the power consumption situation in India, then also the grid can take it care of it, and there would be additional power available in the grid. So the transmission grid is not going to get impacted, and it is envisaged that if all the things that is in planning stage becomes true, then the distribution grid will get impacted by another 7 to 8%. So there is a forum of regulator report available in that regard, because of the distribution system by that time will also change into smart grid. So studies have already been started in Delhi and all, where the feeder design based on the charging station location is also planned. So what happens, like if you have a feeder which is already, I'm talking about distribution right now. If you have a feeder and it is already overloaded and you want to plug in the charging station into it, then it may need augmentation. So in that one, you can, like I mentioned about the OPADR, open point for demand response. So based on that one, you can control, or else you have to augment the grid. So there is a chance that if distribution system doesn't grow the way it is envisaged, then there will be impact of 8% on the distribution grid. You can refer forum of regulator in that regard, or else I can provide the report to you. But there is no impact on the transmission. It can cater. I hope I answered the question.
Okay, sir. Thank you very much, sir. Sir, again regarding the like, there are some like issues here which was mentioned by one of the professors yesterday. Like, means the problem of stability and the problem of like harmonics and all.
Yeah.
So, are you taking care of these things also? Like,
Yes, sir. The harmonics is a issue. Harmonics is a issue, and it is basically from the point of injection, and it deliberately it slowly penetrates into the grid. So, like I was in Nirjuli, I think 2 years back for this power quality measurement, and we when it is a transmission grid and you are operating above 400 kV, you barely see in any harmonics. But if you have a like, but in usually we saw, because there are, I understand there are some melting plants, steel melting plants, arcing and all happens. So you will see even in your 400 kV substation, you will see. So now harmonics filters are installed in many of the places, and whoever is injecting harmonics, there are penalties. But currently, there is no mandatory rule for that one. That when you have a charging station, you have to put a harmonic filter. But yes, in like the charging station that we install at metros, so they ask us about this what is the harmonics level that is injecting by the charging station. So this is one issue that will come in case of distribution. And CA has already given safety guidelines and asked to follow the distribution guidelines for harmonics, but it has not dedicatedly decided anything for charging station. But sooner or later it will come. Season numbers are less; they have not come up with exact rules. But on the other hand, they have told that you have to follow the distribution rules. But yes, that is one issue that will come into picture. Um,
Okay, sir. Thank you, sir. I think there is a couple
to
of questions in the chat box,
Yeah,
most
I'll
especially, sir.
just quickly go through them. Are there any startup research in India working on using blockchain in EV and EV charging and EV trading? Um, as far as I know, we have not come across. There is one company, Interwork, and they are working in blockchain, but I'm not sure whether they are covering energy trading. Yeah, I think they're covering. You can, if you are interested, you can get separately connected to me. I'll try to connect you to them. So there is a company called Interwork. So they are into blockchain and they are definitely into EV charging. I have to check on energy trading for that purpose. What would be the difference in overall pollution level considering electricity still is harnessed mostly by thermal energy? So it is understood that there will be a reduction of 40% pollution if as on day without renewable, if you are using without renewable, you are using electric vehicle. So this is calculated, and I think you can find it in Mahindra research website. You can get that detailed point by point supply chain calculation you can get. I think I have also done some calculation for one of my presentation in ministry. So if you can rightly separately to me, I can provide the data to you. Thank you.
Thank you, sir. Yeah, any other questions from the participants? Uh, I think that's all. I think, sir. I think, yeah, no more question. I can't see any more question. So thank you, sir. Thank you very much for your wonderful presentations and for providing us lots of like latest informations for EV technologies, especially in the charging infrastructure and all. Like I'm happy to know about the Bharat that particular means charging that we have developed in our own country. And also, sir, I would like to extend my hearty thanks to you for your precious time out of your busy schedule. And sir, we are hoping to see you in the future as well, sir.
Sure.
Thank you very much, sir.
Thank you. Thank you, sir. Thank you,
Thank you,
everyone.
thank you, sir. So, dear participants, this is the last technical session, and we come to the end of the last day. And after this, we will have a session on the means it's related to Fit India movement, and we have a session on yoga, common health benefits of yoga. So we will be means having one ARO means which is assistant research officer who works in the Moraji Institute of Yoga, which is under Ministry of Ayush, and he will be joining us shortly at 12 noon. So uh, I can request sir to come early if participants are ready to means join maybe at 11:45. We can make it early. So I would like to get consent from my dear participants. Is it okay if we make it 15 minutes early, like 11:45?
Yes, sir.
Okay, thank you. I would like to hear from others also. Okay.
Yes, sir.
Thank you. Okay, fine. Okay, fine. Thank you, sir. Okay, thank you. So, means at 11:45 we will start the session. Sir will be demonstrating some means common yoga practices and will be sharing some tips. So at 11:45, let's assemble here again. Thank you.